Greetings to all of our friends at the virtual ERTC conference. I'm happy to be able to participate and deliver what Solomon Associates believe is a critical message to our refining community in Europe. And that is that energy efficiency is more crucial today than ever. Solomon believes that energy efficiency in operating plants is more crucial today than it's ever been. The drivers for energy efficiency are changing rapidly and are more complex than ever before. Policymakers are driving change, investors are seeking greener companies, and consumers are demanding cleaner energy. Energy companies know that they must operate more efficiently and deliver financial results while improving sustainability. The imperative to improve energy efficiency in refineries, it is real, and it is now. So it seems obvious that energy efficiency should be an integral part of the refinery's strategy. But this won't happen unless refiners change their historical approach to energy efficiency projects and look beyond just energy savings and consider all the relevant factors and benefits of today. So there is certainly a major case for change. Smaller carbon footprints, lower water consumption, and more transparency are just some of the pressures that are mounting on operating companies and individual refineries. In Europe, you certainly are all feeling these pressures more than any other region in the world, as almost every European energy company has committed to net zero carbon emissions over the next few decades. How companies will achieve their commitments, these commitments, remains to be seen. But one thing is clear, that energy efficiency should be a significant, tangible part of your overall strategy. Energy has long been a significant percentage of annual OPEX, and refiners have been investing in energy improvement projects, particularly when oil prices are high. But more recently, energy projects aren't making the cut because the energy savings alone don't yield the returns that meet companies' internal hurdle rates for investments. But as I mentioned, the drivers for energy efficiency are changing rapidly, and the imperative to improve energy efficiency in refineries is now real and urgent. And while the pandemic has decimated demand, in the long term, demand will not disappear. It certainly won't disappear overnight. Refineries will still need to make all forms of transportation fuels for our cars, our trucks, and airplanes for decades to come. But now, they will need to do so more efficiently and economically than ever before. And for refineries, particularly those in Europe, improving energy efficiency could be a key survival strategy because it can deliver on both energy savings and carbon emissions. So what do you need to do? Before I answer this question, I want to be sure that you all know who Solomon is and that we know something about this subject. Solomon has been benchmarking the refining industry for over 40 years. And over this time frame, we've amassed the world's largest database of proprietary refinery performance data available. We combine these data with the knowledge of the Solomon team, who come from operating companies just like yours. They know refineries and they understand the refining business. They've been in your shoes, understand your pressures. Combining these two knowledge bases allows Solomon to uniquely provide clients with actionable insights that are practical and backed by high quality data. In short, we know what good energy efficiency looks like, and our services and our advisors have been helping companies get there, and we've been doing so for many decades. So now, let me share some facts with you to set the industry context. This slide is showing worldwide energy costs by region for the last 3 Solomon fuel studies, 2014, 2016, and 2018. On a world scale, as this shows, the cost of energy in Europe remains high. While still lower than Asia, in 2018, the cost of each gigajoule of energy in Western Europe was twice that of North America and Russia, and 4 or 5 times that of the Middle East. This would lead one to believe that Western European refineries would be among the most energy efficient in the industry, right? Well, unfortunately, even though these energy costs have remained high, energy efficiency improvement in Europe appears to have stalled. And as shown on this slide, what we're showing on this slide rather, is the relative energy efficiency trend over the last 15 years. And as you can see from this graph, Western European refineries overall is generally more energy efficient than other European regions. But on average, there's been very little progress in improving energy efficiency over the last 15 years. Even more dramatic is the large gap that remains between Western European refineries and the world's best EII refineries. Roughly 30% more energy is consumed in the average European refinery compared to a world's best performing refinery. These gaps exist in all areas of operations: furnace efficiencies, process duty, steam from fuel, and others. It is important to note that these world's best EII refineries are not all new, large refineries. And indeed, several world's best refineries are right here in Europe. The takeaway here is that large gaps remain compared to world's best EII refineries, but world's best performance is possible, even in Western Europe. Whether you believe the maxim of "you can't manage what you don't measure," the data show it is particularly true for energy. So what we're showing here is that energy monitoring indeed leads to lower EII. On average, Solomon data show that there is a 6% improvement in EII, where sites are measuring energy daily on a unit level compared to those that are only measuring energy infrequently or at a site-wide level alone. It is surprising that only 45% of European sites routinely monitor energy consumption at a unit level. 25% only monitor monthly or quarterly, and a full 30% of sites only estimate energy consumption at this level on an annual basis. The takeaway here is that energy monitoring leads to improved EII. I would add that if you're not measuring energy frequently and at a unit level, you better start. We all know that the world economy relies on hydrocarbons and hydrocarbon infrastructure, and this infrastructure and these supply chains cannot be quickly or easily replaced. Therefore, the demand for hydrocarbons and transportation fuels will still be around for many, many years to come. As such, refineries must address this problem, the problem of carbon emissions reduction, because it's not going away. This chart is showing that carbon intensity, as measured by Solomon's carbon emissions intensity metric, is highly correlated to energy efficiency, or our EII metric. While carbon intensity can be impacted by non-energy consumption variables, such as refinery configuration and fuel choice, the silver lining to energy efficiency improvement is the derivative benefit that is achieved of lowering carbon intensity at the same time. In addition, energy efficiency is easier to measure than carbon intensity and is therefore easier to control. So the takeaway from this slide and this data is that carbon emissions add to incentive to reduce energy consumption. This next slide is showing the carbon efficiency index trend over a time frame from 2010 to 2018. And we can see from these data that the carbon intensity trends are very similar to those of the energy intensity trends that I showed in the earlier slide. So, based on the information that I presented a moment ago, that carbon intensity is directly linked to energy efficiency, there really should be no surprise here. However, in my opinion, the surprise comes that energy efficiency impacts not just, obviously, fuel savings, but it greatly can impact non-energy OpEx as well. We all know that energy costs are a significant proportion of overall refinery operating expense, and in Europe in 2018, it was about 50% of overall refinery operating costs. But, and again, this may surprise you, there is also a definite correlation between energy intensity and overall non-energy operating costs. This is clearly shown in this chart, which compares non-energy OpEx versus EII for the European industry. So why is this? The reason is that reducing EII reduces the size of utility systems. This in turn reduces maintenance work and cost, produces fewer maintenance work hours, and in fact, lower site work hours overall. This supports that we need to think beyond the simple energy savings economics of the past for energy projects. We need to do something different. We need to change the way we think about energy projects. We need to start thinking about energy when we plan our maintenance work and strategy. We need to look at the whole picture. The fuel, steam, and power systems need to be considered holistically and with an end state in mind. For instance, replacing one steam turbine generally doesn't save enough water to eliminate a cooling tower, but replacing several over time just might. It is important to think also about overall site economics. For instance, if water is scarce or expensive, energy project economics may become even more favorable. The key point here is that energy efficiency improvements can reduce operating expenses well beyond fuel savings alone. So I ask you, what would your total savings be to improve energy efficiency to world's best levels? The next point that Solomon would like to make is to integrate energy efficiency into your overall maintenance and business planning cycles. As I've shown, the data suggest that energy efficiency can save more than just the fuel savings alone. But will these additional savings push projects above the ROI needed? Maybe, maybe not. But can you really afford not to know? One way to guarantee a sustainable return is to integrate energy efficiency into your maintenance and business planning cycles. The first point is that a robust asset lifecycle management is critical. Sites generally have the information they need, but it may need to be centralized, but then it also needs to be deeply analyzed. How many heaters have been replaced in the last 10 to 15 years? How many have been replaced like for like? If the plans for replacement or maintenance are unknown, then sites should consider improving designs. For instance, world's best refineries have an average furnace efficiency of 89%. This is compared to an average efficiency in Western Europe of 86% for heaters. A site might also consider replacing a turbine with a motor, but standalone, this may not make sense. But looking at the whole system, fuel, steam, power, needs to be considered with an end state in mind. You can't just make decisions to replace a significant item overnight. It takes time, it takes thought, and it takes planning. Some equipment has a long lead time. Maybe it can only be replaced during a turnaround. But remember, all equipment gets touched, whether replaced or a major overhaul every 20 to 40 years. The second point is to use the site maintenance plan as the plan that drives investment timing. For example, CDUs are one of the largest energy consumers in a refinery. We all know this. While it is vital that sites actively clean exchangers, it should not stop there. Look at the big picture. Don't just replace bundles like for like, because that's what you've done before. Consider replacing bundles with new, more efficient designs and design them ahead of time. And finally, consider all economic drivers for your analysis. Non-traditional factors have creeped into the equation. Carbon emissions, ESG factors, public sentiment, whether they have real value or perceived value, are all important to consider today. So in summary, the total value is much larger, much larger than the sum of its individual parts. So I'd like to illustrate the value of improving energy efficiency by sharing with you a brief case study. And as I mentioned, Solomon have for many years worked with clients to improve refinery performance, using our data and expertise to guide and help clients achieve change, sustainable change. This slide is a summary of a recent case study for a North American company with a large refining portfolio. Solomon showed them that the total savings potential for their portfolio is 3 times the fuel savings alone. Please see the bar chart. Many factors will contribute to this aggregate benefit: lower maintenance costs, reduced chemicals, reduced water consumption, and so forth. Solomon helped this client change their energy efficiency paradigm. We showed them that the improvement value was far greater than the fuel savings alone if they approached it strategically and holistically. We helped them map out an appropriate strategy, evaluate their energy management practices, define and prioritize projects, and in general, continue to help them make their new holistic energy efficiency vision a reality. So let me put it in perspective. For this client, it is estimated that this program will deliver ultimate benefits of over $750 million US. So let me ask you, do you look at the big picture when considering energy projects? Do you have a list of energy projects ready to go if a replacement is necessary? How much could you save across your refinery or your refining portfolio, for that matter, if you took this more holistic approach? And finally, how much more would a program be worth in Europe when you factor in the cost of carbon? So in summary, please remember these key takeaways. The first is that energy efficiency is linked to carbon intensity, and energy improvements can contribute to achieving carbon emissions goals, not in their entirety, but can provide a significant input to that process. Number 2, energy efficiency projects can deliver savings well beyond energy alone. Non-energy OpEx is significantly influenced by EII levels, whether up or down, as the data has shown. Next, regular monitoring of energy consumption at a unit level is a best practice and one that has proven to produce lower EII. So if you're not doing it today, please start. Fourth, look at energy efficiency holistically and strategically. Understand the economics and all the benefits of a large EII improvement. Think about what it would take to improve your energy efficiency to world's best levels. Decide how far to go and define the economics for that target. And finally, use your maintenance plan as the plan to drive investment timing. Redesign equipment to be more efficient. Don't just replace in kind. Do the engineering ahead of anticipated replacement, and set the implementation plan by major maintenance timing and milestones. And in Solomon's opinion, companies that approach energy efficiency in this fashion will have the best chance of surviving in the long term and thriving when times get better. So time is of the essence. Energy efficiency in our industry is more crucial than ever. So I ask you, can you really afford not to invest in energy efficiency? Thank you.